Okay. All right. Hello, everyone. It's nice to be on a Zoom call with all of you, people that I know from the internet but have never actually met. Hello, I'm David Asboth, and we are going to do a little bit of amateur philosophy. It is 9 p.m. here in the UK, so I'm going to call it late night philosophy, but you can call it afternoon philosophy. I have brought you a talk in 3 acts. Um, First of all, I want to go through like an actual data science case study that I worked on. And it's a project that failed because I think those are the interesting ones. And it failed for reasons that I think are interesting. Either you have been through something similar, and so again, we can share some trauma, or you're, newer to the data industry, and it might be interesting to see how projects in the wild fail because they don't teach you that in data school, which we all went to, right? And then, unfortunately, we do have to talk a little bit about AI because it's going to take our jobs or something. So we do have to address that concern. But then we will get to the amateur philosophy to tie everything up in a neat ribbon at the end. And amateur philosophy is the best kind of philosophy anyway. Okay, so this case study, let's set the scene a little bit. About, I want to say 7 or 8 years ago now, I was a data scientist in the used car industry. And the company I worked for used to host these enormous used car auctions, right? So I want you to imagine like an aircraft hangar full of used cars coming one after another and people bidding on them, in person and online, selling hundreds, thousands of cars a day across various sites. And we were on the data team working in this problem space. And what we used to do is, well, partly we would field requests like all of you have mentioned, but one of the other things we used to do is sit in on meetings that we weren't technically invited to see if we can find use cases and business problems to solve. Sitting there, seeing what people are talking about in the business without them actually talking about data problems, and see if we could read between the lines and find something where we can help out. Partly so that we don't get fired to justify our existence, which I think data teams around the world have had to do quite a lot. And one of the things that kept coming back, we used to service both the buyer and the vendor side of these used car auctions. So they were everyone in that room was our customer. One of the things we used to hear a lot is, oh, why couldn't you sell my car after the fact? So we would have vendors phoning our account managers complaining that we didn't sell all their cars, right? And this was an awkward conversation to have. Nobody wanted to field these calls after an auction has happened, especially because a lot of the time these failed sales were preventable. Most of the time we knew exactly why we couldn't sell somebody's car, but it was awkward to have that conversation after the fact. And so nobody was talking about this as a data problem, but in the data team, we're like, hang on, like we can allegedly predict things. Maybe we should build a model that can predict the likelihood that a used car will sell before the auction takes place, right? And then we can have a proactive, preemptive conversation with the vendor and say, look, you've got some cars coming up. They probably won't sell for this and this reason. Here's what you can do about it. And then everybody's happy. So we said, leave it to us. We'll build something. And so we thought, okay, well, we need to build this predictive model, right? That's a classic sort of data science machine learning problem. And then we need to package it up in a way that we can then trial it with a customer. So we came up with this idea of calling it an early warning system, and we will produce some kind of application, some kind of web interface, something where you can go and check out, the cars that are at risk and have those conversations well in advance. So that was the idea. And then I went away. We had a lot of data, right? We had a ton of auction data from years and years of past events, and so I could look at things like, what are the factors that affect the probability of sale? And they were extremely surprising things like, why don't cars sell? Well, usually they don't sell because they're too old. So age and mileage is very important. They don't sell if they're too scratched. So if they're in a bad condition, people won't buy them. And then probably the biggest one, because this is an auction environment, so each car had a reserve price set on them, but often that reserve price was way too ambitious, right? Vendors would set a reserve price that doesn't reflect the current market value of that car, and so nobody buys it because the reserve isn't hit, so the bids aren't accepted, and then the vendor can phone us afterwards and complain that we couldn't sell it. And the problem with not selling it is that the next time you try and sell the same car, the buyers have already seen it. And used car dealers are very good at remembering specific vehicles. So if they see another car coming around again and again, they won't buy it. It'll just decrease the likelihood of sale to zero. So we really want to sell it first time, and that means the reserve price has to be, appropriate for the market value. Okay, well, as data people, we know that if we find factors that affect the thing we're trying to predict, we can shove them into a predictive model and things will happen. So I built this thing. Um, I think it was a logistic regression with something like 7 inputs, like really the first thing that you would try. I tried, and it was good enough. In machine learning terms, in terms of like pure accuracy score, it was a perfectly good model. We could use it to trial a future sale. And then, of course, it had to be productized. And so, what that actually means between friends is I did some terribly unholy things to Tableau to make this thing work. And it was a dashboard that showed all the cars and then, flagged the high risk ones in a way that people could go in and click on it and get some information. Okay, so I built something that looked like it could be useful. It, on past data, on the test set and so on, it produced perfectly good results. We were ready to go. And then we were ready to trial this with an actual customer. Now, we found a couple of problems, as you do, right? When this thing goes into not even production, this was just let's try it on an upcoming sale and see what happens and see if we can have some conversations after that sale. But now having this tool in our hands so we can talk about, how the tool performed and then how we could manage sales in the future, like auction events in the future. But two things went wrong. And this is, I think, pretty standard for predictive problems that are maybe not well scoped out or not the right fit. So the first problem we encountered is that the predictions that our model was making were not available at the time we actually needed them. We've probably all seen some variant of this in the real world. So we had an operations team whose job was to enter details about the used cars into the system, into the same database that these predictions can pull from. But this team was so overstretched, there was so much going on. A lot of the time, they couldn't input the data about the cars until the evening before the auction took place, which is way too late, right? If you want to have a proactive conversation with a customer that their vehicles have got something wrong with them or there's something we should do to increase the likelihood that we'll sell them, you can't have it like on the morning of the sale. It has to be days before. And this revealed like a significant operational problem with this whole enterprise. Like we cannot put this into production if the data is not going to be there days before we actually need it. So that was something that we discovered very early on. And then the other thing, which I think we talked about, or you guys talked about in the Discord a little bit as well, which is things that we should be able to do based on our findings are not available for us to do. So, when you build a predictive model like this, you can look at things like feature importance and things, right? To try and get a sense of how you could improve this score, in this case, the probability of sale. What is the most important factor in this prediction? And, the most important factors that came out of this trial were things like your reserve price is way too high, stop doing that. And we had that conversation, or like the account manager had that conversation with the customer that, look, we predicted your vehicles, how likely they are to sell. We did all right. We did a pretty good job of predicting most of them, whether they would sell or not. And the ones that didn't sell, in most cases, it was because your reserve price was way too high. And vendors generally didn't like to hear this at the best of times, that their reserve prices are wrong. But this particular customer that we trialed it with had like a CFO mandated policy of how they're supposed to set reserve prices. So it's like, I don't know, some percentage of current market value has to be the reserve. And the individual vendors didn't have the power or the authority to change that. So here we have a predictive model that can tell you these cars are not going to sell, and this is exactly why they're not going to sell, and nobody can do anything about it. Okay, which is two major problems. And admittedly, we could have trialed this with other customers and taken it and tried to do something with it, but at this point, we then moved on to higher ROI projects. But these were pretty big obstacles. And from this was quite early on, I think, in our data team's life, we learned to ask a few questions before every new project. And I can recommend this, and I think I've seen one of these at least in Discord already. You know, can we make a prediction when we need it? Yes, of course we can build a predictive model. Everybody can do fit, predict, and scikit-learn. But if we try and operationalize, that's the one, this into the business, will we actually have the data available at the time the prediction is useful? Always ask that. And if not, what's the point? But even more importantly than that, what are you going to do if we do give you these predictions? What are you going to do about it? And that's a very telling question because um, if people don't have an answer ready to say, I need you to build this thing that predicts this thing because XYZ, and this is how I'm going to change how I work based on these predictions. If they don't have that answer ready, it's probably not going to be a valuable project, or at least it's going to take a bit more conversation to turn it into something that is actually useful for people. So we started asking these for every new project. And that did, I think, a lot of good for us in our success rate afterwards. So I can very much recommend that. Okay. So I think, I mean, I'll be interested to see in Discord whether people have similar stories. But the kind of the thing I wanted to highlight here is that the failure of this project was not because nobody had the right technical chops, right? We could build the model, the data was there. We could even productionize it to whatever extent. The barriers were all operational. Okay, so what I want to do is kind of revisit this case study, but through the lens of what would happen if this project were happening now in the era of generative AI, which is apparently on the cusp of replacing all of us. I think it's very telling. Um, so what I wanted to do first is to just go through, what did we contribute as a data team? What were the different steps that we had to do as data experts for this project? Something like this, right? So we had to sit in those meetings and identify a business problem, like read between the lines of what is something that we can actually do something about as data professionals. Then we had to do this translation in our heads of how do we go from vendor is upset that we don't sell cars to we could predict the probability of sale before the event happens, and therefore we could build this particular classification model. So turning it from a human business question to a data question that we can actually answer. Then we had to actually explore the data, right? Find all those correlations and things, build the predictive model, productize it somehow. So surface these predictions in a way that's useful to a non-coder, right? Some kind of interface. Actually run the trial with a customer, and then, learn from the results, iterate somehow, or decide to can the project, right? Do something about the result of the trial. I think roughly these are the steps that we followed. Now, whenever someone says, oh, XYZ job is going to be replaced by AI, I always like to think, okay, what are the specific components of that job that AI can do just as well as you and therefore can take over? So let's have a look at all of these and see. Now, you don't have to necessarily agree with um, my view of all of it. I'd be interested to hear any thoughts. I'm willing to have my mind changed, but at this point, right, can an AI sit in a meeting of account managers and salespeople and read between the lines and identify a business problem? I would argue no. And that's because there was so much unspoken context in that room, right? There's the expertise of all the people. Everybody understands who's who everybody reports to, how the business works, which client is more difficult than the other. There's so much tacit knowledge and domain knowledge and data skills in there that were unspoken. And feeding all of that context into an AI, even if it had a context window big enough, it doesn't seem practical and it doesn't seem like reality. So I'm not sure that part we could outsource and farm out to an AI. Could it do the next step? Given that we've identified a business problem we're trying to tackle, could it turn it into an equivalent data problem? Maybe if you typed out enough information, again, you'd have to give it a hell of a lot of context, I think, to to get it to do the same thing that we did. But maybe, conceivably, possibly, I'm trying to be charitable here. Could it explore the data once that data question is out? Now, I don't know how many of you actually tried to let it loose on a data analysis and like a proper data analysis, not just like generating some pandas boilerplate. Um, yeah, it can do some of it, but I will refer you to Randy's piece called Data Cleaning is Analysis. I think that pretty much answers why I'm not convinced that exploration is something we can just hand over to AI. It doesn't really think critically about it. It will just write some pandas boilerplate with some generic EDA questions. Maybe it'll find missing data and then it won't contextualize it. So again, not something I would necessarily want to outsource. Could it build a predictive model? I mean, sure. I think that's probably the part that's easiest for replacement. And I'd be happy to do that. I'd be happy to let the AI do that part of it. I'm not a big like machine learning model tuning geek, so I would happily hand that over, um, with the appropriate supervision. But let's be charitable and say, yes, it could do that part. Could it take those predictions and turn them into a product? Again, I would argue the code, it could. Like if you said, build me a Shiny app or a Streamlit app or something that surfaces the model, the predictions from this particular model, yeah, it could probably do that. I haven't tried building like Streamlit apps with it, so I don't know how good its knowledge is. But the part where it makes software that will be used by humans and the specific humans who are your target audience, I don't see it. Right. Again, it's that context problem. There's so much context around who's going to use it, how are they going to use it, that I'm just not convinced we're there yet, if ever. Um, could AI autonomously trial this with a customer? I mean, is it going to have the same relationship as an account manager does with a customer? I don't think so. And I think the customer would be really annoyed if we just sent like a bot to do this, right? I just don't see how that would result in customer satisfaction. And then could it take all of this and then learn from its mistakes, or at least like appraise the situation and figure out what the next steps are? Again, there's so much business context required to do that well that again, I just don't see it. And maybe this is an AI skeptic view, but if we look at these, it's not done great in replacing us. And generally, I think that AI is good at doing the techie stuff. It probably will get to a point where it can write decent code, train models, do all that kind of stuff. But there's so much human input required in the data analysis process that something that is a language model, a text model at its heart, I don't think it's going to replace it. And people say, oh, but it's not AI that's going to replace you. It's someone using AI that's going to replace you. Um, I always think like, could you give someone who isn't a data person and doesn't have those data skills Could you give them unlimited access to the best large language models, and could they still do an analysis the same way as someone who has been in the data trenches? Again, I'm not convinced. And that sort of brings me on to the amateur philosophy part, to put this idea of AI replacing us, or AI powered people replacing non-AI powered people, or whatever, into perspective. Um, so first of all, the ship of Theseus, if you don't know it, it is a very interesting philosophical thought experiment. So if you imagine Theseus has a ship and bits of it break, so like a plank rots and he needs to replace it. So he replaces that one plank. Ship is the original, but one of the planks has been replaced. And the thought experiment asks, is that the same ship? Is it still the same ship? And yeah, I think probably most of us would say, yes, it's probably the same ship. And then the thought experiment goes on, what happens if every piece over time is replaced? So the ship looks identical at the end, but all the individual pieces have been replaced because they've broken over time. Is it still the same ship? And then you can have lots of very interesting conversations about, what makes a thing a thing. It's very interesting. And that's sort of the question that the ship of Theseus thought experiment poses for us. But this always reminds me of data analysis, because if you go back in history to people doing data analysis on like clay tablets in, I don't know, ancient Mesopotamia, all the way to people then using abacuses, spreadsheets, and now typing things into ChatGPT to get Panda's boilerplate code out the other end, at a glance, all of these jobs look completely different from each other, right? And certainly one of those people couldn't be dropped in to do the other person's job. But the reason for that is that the tools have changed, right? So we have changed all these planks in the ship of data science over time. But the philosophical question is, has the job of a data person, an analyst, data scientist, whatever you want to call it, over hundreds of years, has it really changed at its core? And I don't know, I still think, and my argument would still be that it hasn't really changed, right? This is one of my absolutely favorite data science memes. I think this came out around the time of the NormConf a few years ago, right? Whatever you call it, whatever your specific toolkit, I still think data analysis at its heart is a human to human thing about solving somebody's problem. Happens to be numerically, happens to be with data, and it happens to be with whatever tooling you currently have at your disposal. But I think the person doing it with clay tablets back in the day to the person doing it in Snowflake today is still at the heart doing the same job. And all we're doing is we're constantly replacing those planks, but I think the underlying essence doesn't change. And that gives me hope in this AI world that at some point the hype will die down. At some point we will settle on the places where it makes sense to fit AI into our workflows. But will our job, such that it is, be redundant completely and be replaced by something completely different? I just don't see it. And I think that's a rather hopeful thing to end on. And hopefully time will bear that out as well. So thank you. That's me. You can find me online, also in Randy's Discord. I also have a podcast which I always forget to tell people about. Again, that's lots of AI no hype stuff, which you can listen to. I also wrote a book called The Well-Grounded Data Analyst. So if you're interested in like real world data projects that you can attempt, you can have a look at that. And if you buy the hard copy, it also has some of Randy's words on the back, which ties nicely into the conference, for which I'm still very grateful. So thank you.
Thank you. Oh man, I remember the words on the back of that book, and I'm like, am I allowed to write that? Whatever. And they published them, so
They
cool.
did. No one batted an eyelid.
Yeah, that was amazing. All right, we have a minute left, though. I do want to. I don't think anyone had questions because we were all pretty much just nodding in agreement the whole way. You did spark a bunch of philosophy questions
Good.
along the way.
Good.
Um,
I'll be interested to read them.
yeah, the ship of Theseus. I'm like, what happens if you take the parts that you took out of the original ship, build a second ship, and now you have two?
Yeah, but then it starts to fall apart. The analogy to data science starts to fall apart.
Even then, though, it's like, which one is the real one then? Because philosophers love trolling each other. That's all I can say. Okay, there's probably more chats, but I'm going to let the other David take over. I'm just credit to where it's due. This David has spent all night up in New Zealand, joining us when we all thought he would be sleeping. So yeah. All right, I see your slides. You're still muted, so just make sure that that is good on your end.
And I think we're good.
All right, so it is all yours.